Foundations of Business Analysis students, and welcome to this video presentation on the bivariate regression. The bivariate regression is a test for association that we carry out when we are testing to see whether there is a relationship between two variables. We call those two variables y and x, which are the dependent variable and the independent variable respectively. Before we jump into Excel and have a look at how to perform this test, let's just have a quick diagram as to what the regression model is all about. So here I've got on the screen an example of how we carry out a regression model. The diagram at the bottom shows a scatter plot. Each of the dots represent a particular variable's value for variable x and variable y respectively. We can plot all the scatter plots from within our sample, and we could visually picture a line of best fit that follows through each of those scatter plots. How the regression model works is that it seeks to mathematically define that line of best fit. The way it does it, well, if we look up the top here, if we think about mathematics, mathematics tells us that the equation of a straight line can be defined as y equals mx plus c. Y being the y value, the value on the axis here, m being the slope of this line, x being the x value, and c being the intercept. So where does this line intercept that y-axis? In statistics, we slightly redefine this equation. Exactly the same equation, but we just use different terminology. We say y equals beta naught instead of the c, plus beta 1 instead of the m times x. Now, if we think about this equation of a straight line, what we need to do is we need to work out how can we actually define what is the line of best fit. How can we define what line best fits the data? The way that actually works is that statistics packages look at every single observation. Take this point here, for example, and for that observation they'll measure what's called the residual. The residual is, for each point, the difference between that point and its expected value, which is the value on the straight line. We can measure the residual for every single point within our sample. The line of best fit within our data will be the straight line that minimizes those residuals. However, we don't want the positive and the negative residuals to cancel out. So what we actually do is that for each line, each potential line within this plane, our statistics package will estimate the residual and square those residuals, because we know squared values are always positive. And it will seek to find the straight line where the squared residuals are minimized. Once we've got the equation of that straight line in this form here, y equals b naught plus beta 1x, we use that regression model to perform our test for association. Now the way we do it, if we think about our scatter plot, when we look at a scatter plot, the way we see an association is there is a trend in the data. If that trend is upward sloping, there is a positive association, or downward sloping, it's a negative association. Therefore, in terms of testing for association, what we're really focusing on is the slope of this line of best fit. That slope of the line of best fit is this beta 1 term, also called the coefficient. So with the regression model, once we've estimated the equation of the straight line that best fits our data, we then look at that coefficient, that beta term, and we perform a hypothesis test to see whether the coefficient is different from 0. A positive significant coefficient will mean a positive slope, therefore a positive association between the variables. A negative significant coefficient will indicate a negative relationship. So the way we do this in Excel is as follows. What I've got open here is the real estate case study, and I might be interested to see whether there is a relationship between the sale price variable and the size of the land variable. So to estimate my regression, I select Data, Data Analysis, and then Regression. So in this particular case, my two variables, I said before, my bivariate test for association, two variables are y and x. My y variable, we call that the dependent variable because that is the variable we're seeking to explain. So that is my sale price. My x variable, I'm going to include land size here. Now I'm going to ask for a plot of the residuals to be reported, and I'm going to get my regression output to be reported on the same page, cell O2. I then click OK. So this table that we can see here, this is our output from our regression model. A few things that we need to focus on. First of all, up the top here, we've got a measure called the R squared. The R squared gives us the measure of the explanatory power of the model. That is, the R squared can be considered as a percentage, in this case 4.69%, and that tells us that our model can explain 4.69% of the variation in sale price. The higher the R squared, the closer the R squared is to 1, the better that our model fits the data, the stronger the explanatory power of the model. However, the most important thing we focus on is down here, where we look at our coefficients. Okay, our x variable, our coefficient is that slope. The slope of this straight line is 16.36. But what we're most interested in here is our hypothesis test. Our null hypothesis that we're testing is that that slope equals to 0. There is no association. The alternative hypothesis is that the slope is different from 0, hence there is an association. In this case, we look at the p-value. It's less than 0.05. Therefore, we can reject our null hypothesis. We've got a positive slope, which means there is a positive association. Hence, as we'd probably expect, there is a positive association between house price and land size. So, the bigger the size of the block, the more expensive the house will sell for. That's our examination